So hello and welcome to the DV Digest. My name is Brody and this is your monthly digest of insight from design verification leaders. Now today on the podcast we have Deepak Manoharan. Deepak is currently the global verification lead at ARM and he's previously spent time at Microsoft, Qualcomm, Marvel, you name it. In this conversation, we talk about the ever-changing verification landscape and how Deepak thinks you should assess new tools and avoid bloat. I think it's a super fascinating conversation. We talk a bit about the fundamentals, but also how to really keep up in this ever-changing landscape. I really hope you enjoy. So Deepak, welcome to the show. I appreciate you coming on.
Thank you, Brody. Thank you for having me today. It's truly a pleasure to meet you here. And I've seen a lot of your episodes and it has been really good. So thank you for having me here.
So jumping straight in, obviously as designs have become more complex and larger, we've seen verification move to the biggest bottleneck in the design flow. Are new tools and new methodologies helping or hindering us to be able to close that coverage gap and close that bottleneck?
Very good question. Actually, having spent more than 25 years in the industry, one thing which is very clear is design keeps growing in size and complexity, and it's pretty typical, right? In almost in every industry, it's not unique to AI, to silicon, right? It's almost in any industry, complexity keeps growing, and we have to become effective. And if I have to jog my memory lane, when I started, like we used to do verification using Verilog, right? And then there was Vera. In parallel, we had a language called SpecMen-He, and then came OVM. From OVM, in parallel, that's when the verification methodology was started by the EDA vendors in order to make things a lot more structured, in order to reduce the time it takes to build a silicon, right? That's how RVM came up, VMM came up, then OVM was there. Then everybody got together and said, let's all unify, and that's how UVM was born, right? And then UVM has been pretty stable even today, and it's an Accelera standard, and we have been using UVM. But now UVM is not going to fix all the problems. When the SOCs become big, all of these languages are all tools. A good engineer needs to know which tool to use for which purpose. We have all these tools in our arsenal, and we need to pick and choose very smartly, understanding the time we have on hand, ensuring that we can find that important bug which will create a problem if we really miss it. And we also have to keep time to market in mind, right? So it's a balance. So that's how I really see all of these languages, right? So for IP verification, I would say UVM is very good and effective, and it's widely deployed. But the moment you step up your ladder and you go into SOC verification, where you have different processors, you will have to execute things on a processor, that at that point, UVM may not be real. UVM is very lean. You still have to write your own C code, or you will have to use a language called Portable Stimulus Standard, which I'm a big fan of, where you can actually model your design and then you can verify your silicon by working hand in hand with architecture, right? And then you will have to be very smart in using simulation platform, emulation platform, FPGA, and on top of it, like an horizontal formal kicks in, right? So you have like multiple tools that you need to use. And then as an icing on the cake, now we have AI. Everybody wants to use AI. They almost, it's like a joke, right? They want to use AI to make sure they can tape out a chip without doing any verification. I'm sure it's going to take a long time, but that's how folks, that is exactly what everybody is aspiring to really do as we march forward.
So we've seen loads of new tools and, like you say, loads of new AI tools to try to close the coverage gap and etc. How do we navigate this world? How do we decide which tools are relevant and which we should be adding to our workflows?
Very, very good question, right? Always a lot of new tools will keep hitting the market. There will be folks, because every product is it's for everybody who comes with a product, it's going to have a unique value proposition. And everybody is going to say that by adopting this product, you're going to get a benefit, right? But now there is always a cost of migration. There is a cost of adopting a new tool. Every company, every successful company out there, somewhere everybody starts small, and there is a lot of tools and methodologies that becomes part of the core DNA of the company, right? And so there is going to be inertia. So now we cannot really throw away everything in no time, even if the other tool that's coming out or a new language is out of the world and it's better. We have to be very thoughtful, very methodical. Upskilling is very important. Unless and otherwise there is a dire need that it is going to make a significant difference to the end product or our end customer, there is no need to change. The best thing to do is don't change if everything is working fine, right? I'm a very firm believer in that. And also, though you said that it's verification is a bottleneck and it will always be a bottleneck, I personally have my different experience, right? I've had some very good mentors, and I've been very fortunate in having them. The reason why I say that is a job of a verification engineer is to make complex simple. It is it is very important to divide a problem into manageable parts, follow the process, be very methodical, and try to reduce the number of times we have to be reactive in a life cycle of a project. If we can plan effectively, have less is more. If you have to have 2 or 3 tools or languages that you have to work with and well established processes, you have less dynamic variables, so you will be able to reach your goal in a very timely fashion. It's not about saying how many tools we used, how many languages we used, whether we use this AI. At the end of the day, if our chip doesn't work, if a company is not going to make revenue, who bothers about the language or the AI tool that we are using, right? Customer is king, timeline and schedule is even bigger. That's how, at least, I have been thinking in all my years of working on SOC verification. Right?
Yeah. Okay. So, what do new tools have to do to impress you then? Are there any sort of key metrics by which you can judge a new tool methodology such that it becomes worth it to make that transition?
I think one of the first things that comes to my mind is backward compatibility, or trying to not, again, resistance to change is a very big thing that is there in almost every industry, right? And it takes time for folks to adopt. We all have to keep learning. We all have to have a learning mindset. That's given in this particular era, right? Again, any new tool, let's say if now I'm running a team or I'm responsible for a team, I cannot really come up with a new innovative idea and say, you are going to use it from tomorrow. Trust me, nobody would really even listen to me, or that is bound for a failure, right? So any product, if it solves a problem, if it helps the engineer to reach from 0 to 100 in, let's say, 20% less time, we don't have to go and pitch, or we don't have to go and convince any individual to use it. A good product will always find its customer, right? I think we have to listen, especially when I'm doing my, when I'm listening to a new tool vendor coming up with any kind of an initiative. The thing that I'm trying to understand is what is the adoption time? Is this going to give me at least a 40 to 50% improvement, right? Because if it is a 5% improvement, in my mind, what I think is I'm going to spend 20% more to upskill or to overcome the team challenges. And so it is going to be a net negative, right? So you will have to really, and it's not a single word answer. There are multiple factors that you have to really consider. And at this particular time in the era of AI, it is happening more and more. I have multiple folks who come in and will make a pitch saying, oh, AI is going to allow you to automate everything. It's going to change the way we do test planning. You can shift left and you can reduce your chip development time by 50%. I'll be like, Excellent. But the fundamental, which having worked with AI tools, one thing which I can tell you is garbage in, garbage out. I'm a firm believer in it. They talk in verification, everybody talks about e-specification, right? There is this wonderful tool which will understand the document and then it will give you a great test plan. I agree with you. But what if the input source document is not there? That's where human brain is very powerful, and that we have to be very logical. We have to be very thoughtful. I'm not saying innovation is not right. Innovation is very important, but anything we do should be with logic, with our product, and with our customer in mind. Right? At least that those are the three fundamental principles that I always think all of us should really be thinking about and be very self-aware.
Yeah, yeah. This might be a bit of a tangent,
Yeah.
but what are you guys doing to make sure that you have, clean data, data integrity? Is that something that's become more important to you?
It is actually data analytics or data science is extremely important. And the reason is data can tell a story, but it also depends on the who is going to look at the data. Data, you can tweak the data to tell a positive story or a negative story. So I don't want to go into a philosophical landscape, but in general, from a verification perspective, we have to be very objective. Objective metrics are key, and that needs to be standardized for any successful project, right? I can only tell you a very funny joke if it helps, right? If you're going to count an engineer's contribution by the number of bugs that you find, once in one of the companies that I was interacting and working with, someone told that, hey, you're going to be measured by the number of bugs that you're going to find. And then in our SOCs, you have a lot of data buses, right? Like 128-bit, 100-bit buses and stuff like that, right? So one of the engineers, for every bit, they filed a bug, right? So now it's like 100 bits, 128 bits. Now they found 228 bugs, right? But it's just one bug, right? So now if you look at the data is going to tell you the wrong story. So that's what I really meant by it. But fun apart, objectively, in any verification, there are few specifics which I personally use on a day-to-day basis, right? What is your bug curve, right? How many bugs are being found in every IP that is part of the SOC, right? What is your coverage? Coverage, both code coverage and functional coverage, right? And how many test cases are there in your silicon? So what that tells you is how much time or how many tests are there in development for you to achieve your desired coverage goal. And then once you finish a project, you also have to be very thoughtful in reducing the number of tests needed to meet the same coverage goal. Why is that important? Because more number of test cases means more simulation time. More simulation time means more tests means more people are needed to maintain those test cases. So that also increases the cost to the company. So we all have to really be very thoughtful in achieving the desired goal using our resources, both people and compute and our other resources effectively, right? So that is a core job responsibility of a verification engineer and the verification management team in any company. That's how I see it. So these are the key things from a data. And now once you have data, what it helps is when you do projects over projects, you can train the data. And using that data, this is where AI comes in, right? So you can see a pattern, you can predict effectively, and you can also make sure you can make well thought, informed decisions that resonates with your product that you're building. That's how I really look at the complete landscape.
Yeah. Okay. At risk of this becoming a sort of ad, is there anything recently that's really impressed you in terms of a new AI tool or any sort of new methodology? Is there anything that's really stood out to you recently?
Recently, I don't want to really name a specific tool or really make it like a marketing campaign, but I have reviewed few things that's happening in the AI landscape, right? There are few folks trying to build AI agents. So there are few things, but still the problem, though they are impressive on paper, the challenge that I really see is no solution is going to fit all, lines of business. So a mobile SoC, a SoC that goes, let's say, into an automotive SoC, a product. Let's say we are building a product for a hyperscaler. Everything has some unique differences, right? So, like any product you build, you have to identify your customer, and having that unique competitive or unique differentiator is key, right? So there are few products of that nature, but I feel any new agents that folks are trying to develop, when they cater to a specific market segment, it becomes extremely impressive, right? I think that is how I really see it. And there are few things which I've seen in the recent days, which I'm still exploring, or I'm constantly in discussions with them. But I'm sure there's going to be a lot of new things around AI that's going to come in the next 2 to 3 years. That's my take.
What do you think of the sort of open source landscape? So tools like CocoaDB, Verilator, and do they have a place in kind of larger organizations like ARM?
I can't specifically specify about ARM or any particular company, right? So in general, let me just keep it a little bit general. Like CocoaDB. I've used CocoaDB, and I like it. But where I really see it useful is when I want to learn something, right? When I really want to adapt and quickly, develop a bench around a small design that I'm really playing with, I tend to use CocoaDB. But now, having said that, in the world of AI, building benches have become very, very simple. Like CocoaDB, in my mind, it's good framework that it creates around a design that will help you get going, right? I think that is what is going to happen in the future right now. I have not been coding like the way I used to code before, let's say 6 or 7 or 8 years, I should say. But recently, when I really feel like I want to really start doing something, these days, even though I feel like at times I feel rusty, so I just go into ChatGPT, and then I'll just open AI, and then I would really pick one of the designs and say, okay, can you please give me a bench around this, and in no time I'll have all the framework. But then what I will really learn is, it gives me the framework, but still I should have the muscle memory to know how to use that framework. That is where the value comes in. So that's how I really see CocoaDB or any test bench. Test bench is not going to be a barrier anymore, right? That's the good thing. Like if you really use most of I don't want to name a particular AI tool, but any language AI tool that helps with coding, right? Coding, the barrier to entry is very, very less. If you can ask the right questions, if you are curious, if you can prompt effectively, if your communication is strong, you can have the AI tool produce a lot of things. But now you should have the knowledge to find the problem if the AI is hallucinating, or if it is going to give you something which is wrong, you should still be able to spot it. So you can't copy and paste it and assume it was going to work. But if you have invested in your organized learning, and if you have done it for a long time, I am very happy to see the kind of knowledge companions that we have in the world. Right.
That's interesting, because there's a question that I've asked a couple of my guests actually. There's been a common theme around AI and the changing verification landscape. You mentioned kind of prompt engineering there. What skills and tools do you think verification engineers should make sure they have refined as we move forward into an obviously changing landscape of LLMs and AI and different tools? What skills do people really need?
The thing is, I think constantly they will have to be stay up to date with all the latest happening in the industry, right? Depending on the industry that they are in. Let's say if they are on a mobile industry or in the infrastructure industry, they need to know what's happening out there, right? And then if you really start following these blogs or industry trends, there are set of interfaces which are going to be pretty standard. Everybody wants to go towards standardization, right? So a DDR, PCIe, could be a chip-to-chip link. Most of the things, like if you follow OCP, framework, like most of the things, they want the industry to be central, unified across a common standard. So you need to understand that, right? And then what is going this is my way of looking at it. In the future, I view everything is going to be like an IP catalog, right? When I say IP catalog, there are going to be these standard interfaces in the cloud, and you will pick and choose what are the various IPs or versions your particular SoC is using, right? Once you have that catalog, you will be able to create a AI ecosystem or your own AI cloud, saying, in my body of work, these are the various things that is working. And then, like, we all have to keep reading, we have to know the IP or the infrastructure that is going into our SoC. So go through everything, make sure that we don't have to memorize or remember like we did it before a few years. That's the good thing with AI, right? Because we have somebody else who can remember on our behalf. But what we need to do, this is what I keep learning on a regular basis. We have to be curious. We should know what questions to ask and where to search, right? So that, and again, please, I really think everybody should take a prompt engineering course, right? I did take a personal course. You don't have to be a silicon engineering expert or expert in the industry, but just go be curious and pick a prompt engineering course, because you can't, every click or every search is expensive. You're going to use tokens, right? So now, if you have to be effective in utilizing the AI resources provided, you should also find a framework that actually defines your question. So anytime when I write a prompt, I'm not able to remember right now the whole sequence, but there is a particular order in which I will follow a prompt, saying context. I almost will also say, this is my IQ level. I want you to respond at this level so that I can understand. And then be very specific. Am I a person who appreciates verbosity? If I don't appreciate verbosity, all I need is a concise, specific response. I would say that, right? And I don't use one AI tool, right? There are multiple, which is again amazing, right? Like, yes, I use ChatGPT a lot, but I'm a very big fan of Perplexity, right? And recently I started using Comet. Comet is the browser around Perplexity. It is terrific. So it allows me to do my research so quickly, right? So you asked me what is one thing that impressed me from a new tool or new software, rather than more from the AI space. Most of these software research platforms that comes up in the industry is amazing, right? Because before several years, I used to buy like 5, 6 books, read through, go search. Even on Google, there is a way that you have to do your search in order to get your results. All of those things are all gone these days. You can do it and you can have access very quickly. So be curious and you can learn a lot.
Yeah, I find that really interesting. It seems that you are very bullish on AI. Obviously, you have some concerns about bloat. What are the wider concerns that you have about kind of rushing into this AI frenzy too quickly? I know you've mentioned some of them, but what should people be wary of?
I'm concerned about a couple of things. One is, I call it the AI bias, right? By AI bias, what I mean is, everything that we see in AI is trained. It's a language. It's an LLM trained at a particular point in time, right? And now anything that has been trained, there are going to be always certain biases, and there is something called reinforced learning, right? AI keeps feeding on itself. So exponentially, those biases can grow. And why did I really say this? Now I want to apply this paradigm onto the verification. Verification engineer's job is always to question or have a sense of doubt in almost everything, right? So I don't want an AI tool. Like, think about it, right? Let's say that you take a design, you feed it to AI, and AI can tell me, hey, where are the bugs? And it can really find it magically. It's awesome, right? That's the rosy picture, or that's the dream that everybody is trying to go into. But it depends on the way the whole, uh, you know, training is done, the way we really. So those biases are my biggest concern, right? I can only draw a parallel paradigm. I think I forgot the museum in Paris where there was a recent heist, right? So if you really think about it, I was reading about it the other day. 100 years of security, so complacency is there, right? So there is some kind of. It's not about it was working well for 100 years, but it is just one escape, and now everybody is going to talk about it. It is very similar in verification. Nobody talks about the bugs that we found. If at all, if we miss a bug, and if we have to cause even one respin, nobody cares about whether you have AI, whether you did everything. You're done, right? And that's our job, right? So we always. I'm bullish about AI, but I do not really think AI can completely. It is, I would say, 90% accurate or 80% accurate. Depends on. I would give a percentage accuracy. So I would still use AI to move faster than the speed at which I was running. If I was running at 100 miles per hour, I can probably go at 110 miles per hour or even 150 miles per hour. But if I'm going to say that now I'm going to cruise at 1,000 miles per hour, I don't think I'm not so bullish, right? I'm a bit conservative, but I still see value in it.
Deepak, I genuinely appreciate you coming on.
Absolutely.
Super interesting conversation. I think some
Thank
fun
you, Brody.
lessons there that people can take away from.
Absolutely.
Have a fantastic day, mate. I appreciate
Thank you, Brody. Thank you so much for having me today. It's such a pleasure talking to you. Have a wonderful day. Bye-bye.
Cheers, mate. Bye-bye.
Thank you.